natural resource management issues. Yeah, thanks for doing the recording, Becca. Of course, I forgot that. Okay, so we are really lucky, and I think today I'm thinking that we have a smaller audience today, and I have a feeling that it's because of the fires. And I just want to say I wish all the folks that are working on those fires and the flooding, we have flooding happening here in Flagstaff from monsoons. I wish them all the best. And last summer, it was really similar. We noticed much fewer people, and it's because of, I'm sure, of the fires. So they're in our hearts, that's for sure. And this is recorded, which is great. So for those who are unable to see it, we'll make sure that they get the recording. But we're really happy to have Martin, who is the Biomass Program Director of the Watershed Center. And Martin's presenting on wood wool cement, a scalable technology for wood infrastructure deployment utilizing small diameter conifers. And Martin, we're really excited to hear about this because we were talking about this during the last call. So I really appreciate you taking the time, and I'm going to hand it over to you.
Yeah, thank you, Anne, for the invitation and the kind introduction. Yeah, Martin Twer, I'm the Biomass Program Director for the Watershed Center here in California. The mothership is up in Trinity County, Northern California. I am based out of Grass Valley in Nevada County. I have one fire 70 miles away, one fire 100 miles away, one to the north, one to the south. But so far, we're still fairly safe where we are, but certainly keeping an eye on things. And yeah, hope for the best. And prepare for the worst. I have my go bag at the door. If I suddenly disappear, then you know why. So okay, I'll be sharing my screen here. Can you see that now? Excellent.
Yes, we can.
Okay. So I'll start with a question. If I told you there is a building product that has a track record as a building material of 100+ years, it's fire, water, vermin, termite resilient, wet, dry rot, and freeze thaw resistant, has several favorable thermal and acoustic properties, is suitable for prefab and modular construction, utilizes small diameter trees, which we have plenty of over here, and has a lower specific weight than steel, concrete, or CLT. What would your response be? Yeah, right, I got a bridge to sell you. Yeah, I know. Or where, how, why are we not using it? So don't tell me now, but keep that in mind as we go through this presentation. So what I want to talk about is wood wool cement. I gave it the title Scalable Technology for Wood Infrastructure Development Utilizing Small Diameter Conifers. I've given this presentation a few times now. It always changes a little bit. And yeah, I'm glad to see Tom on the call as well, since we're working on a RFP to get a market study going for this. Wood mold cement board is nothing new. It's been around for over 100 years, at least in Europe. Maybe some of you are familiar with it, with the term cement Excelsior board, and it's a mineral bonded natural fiber. Maybe you've seen it, but maybe haven't noticed it as such. You can see it in on the top left picture there. It's used as acoustic insulation in a lot of different facilities. Can be movie theaters, sound studios, office spaces. So if you're in an office with a dropped ceiling and you look up, you might see these this what looks like pressed sauerkraut panels in the ceiling, just to cover the mechanicals. I'll be talking about two different categories products. One is these panels that are between 1/2 inch and 4 inches thick and are manufactured in these larger sizes, 2 feet wide and then 8 to 10 feet long. and then another product that I'll talk about later. The inputs, what goes into the product, are very simple. It's just these wood strands, ordinary Portland cement, and water, and that's pretty much it. It uses small diameter trees between 4 and 11 inches, and the length between 6 and 15 feet. So it's all material we do have in vast abundance of, and yeah, often don't know what to do with it. There is a nice YouTube video. I'm not going to play this now. I'll probably put the link in the chat box later. It's from a German company, but there's no text. It is all subtitled, and it'll show you the process a little bit. These are some slides, just what goes in and what comes out. Starting the top left, the logs are delivered. As you can see, it's a cut to length method, which is the most common method in Europe being used. The whole tree is not as much of a thing there. And then it goes through a debarker, and then the logs get stored out in the yard for another 6 months or so, not only for humidity and moisture content to adjust, but for tannins and sugars to settle and cure, because that'll affect the binding with the cement. After 6 months, it goes back to a factory, gets cut into these 2-foot long pieces, goes into this. It's kind of a shaving mechanism, and this wool-like material comes out. And maybe you've seen it as packing material. Sometimes fancy wine bottles are just cushioned with this rather than this plastic popcorn or newspaper. So that's where many people here have seen it before. The application is, again, mostly in the US as acoustic ceiling and wall panels. So in parking garages, that's an IKEA there, top in the middle, swimming pools, top right, shooting range, and then in the lower row there, and either residential construction or in office spaces and other public spaces. As you can see here in the previous picture, it can come in all sorts of textures and shapes and sizes and colors. So there's a lot of creativity possible with this material. Another application is on the exterior. The top row, it's a remodel of a building. I think it's 150 years old, and it just needed to be retrofitted, upgraded in terms of energy efficiency. So they used these panels and added some EPS foam for insulation, additional insulation, and just put it on the outside and the siding. Because these individual wood strands are encased in cement, that's what makes them water resistant. That's why it can be just applied to the outside of a building without any other siding or as such. The lower part, they built a whole, it's more a garage than anything, just out of these 4-inch or 6-inch thick panels. Here are some properties that I mentioned earlier. The thermal insulation, R value is 1.87 per inch. It has a relatively high specific thermal capacity, which means that's your thermal inertia, right? If a space heats up, or if you use it in a building and the outside gets hot, it takes a longer time for this material to warm up or getting inside the building, warming up. Vice versa, when things are cooling off outside, there's some heat storage or thermal storage effect. That lower table is from the Veterans Administration Master Specifications. So some of this material is actually in building codes in the US. And it shows you that R value, again, that thermal insulation, and then NRC is a noise reduction coefficient. So for acoustic insulation. I know that mass timber and CLT is the big excitement these days. That's what we hear most about. But this material plays well with mass timber, as you can see here. Either these arches and beams in the lower left. Again, that's a swimming pool where all the structural parts and pieces are mass timber. And then the sound and thermal insulation is done with wood wool cement board. On the right side, you see just behind the railing, you see the panels again in a combination between concrete and mass timber. So these were the thin panels up to 4 inches. And then a manufacturer in Sweden developed full wall elements. And if you're familiar with how CLT panels look like, how they get, how they are made, how they're assembled, and how they end up on a construction site, this looks very familiar, right? These panels are cast at the factory and then transported to the site and just assembled. Between a foot and over 1.5 feet thick, length up to 20 feet, and then the width between 9 and 10 feet. This is what it looks like. Again, if you've seen CLT panels, if you have seen SIP, structurally insulated panels, that's the sandwich of plywood with EPS foam in between. These elements just get delivered to the site and then assembled. So you can have a building on a foundation within 48 hours, right in with a roof on it. This is how it comes together. I don't know if you can see my mouse pointer here. So these are the panels, and then this gray bar in the top and these columns, that is concrete. And when architects and engineers spec these buildings, they base their entire load calculations just on this concrete ring beam and the concrete columns. So they don't assign any structural load-bearing value to the panels themselves, which should make it easier for engineers to spec these things, and as well, hopefully getting it through building codes in the US, because concrete is a common material that people know here. So just designing it based on this concrete and then using or calculating the panels just as thermal insulation, acoustic insulation, but they have many more other properties. This is, again, how things go together. Top left, that's a building where the wall elements are what we just saw. And then there are roof boards as well. You can see little dowels with the red dot in the middle. And in that combination, they reach a 54 pounds per square foot roof load capacity. That's a lot. They had this example of Mr. Gobi, the elephant. They put him on there, almost 4,000 pounds. Put it on one of these roof boards, and it held up. So for places that have high snow loads, we don't get it much here, but my friends up in Montana, I know, do. If we go up in the Sierra Nevada here, up to Truckee, they get multiple feet of snow every winter. So you have a product that can make up the walls as well as the ceiling, as the roof. And the span or the distance between the rafters is not the 20 or 24 inches that we have in conventional construction. That's between 6 and 8 feet. So it comes together much faster. So this is just a collection of different applications. Lower left, the manufacturing facility. And as you can see, it finds application in all sorts of buildings, from residential structures to office building, public buildings, high rises, again, where the load bearing, the structure is based on steel and concrete, and the wall elements provide sound and acoustic and thermal insulation. Here, a few properties. Because the material does not, or the wall elements do not exist here, I had to borrow some fire classifications from Europe and Canada. But it is fire resilient. The flame spread index and the smoke developed index, these are ASTM US standards, and they tested these ceiling and wall panels for fire resistance. I added some for comparison at the bottom there, the R value again, and this, looking at the California Title 24, that's the building energy efficiency code. A exterior wall with this material would be 11 inches thick. If you want to do the same wall with CLT, it would be almost 17 inches. So if you want to use a lot of wood, that might be a good thing. But again, CLT utilizes mostly mature timber rather than the 4 to 6 inch or 4 to 11 inches diameter material. So that was the whole building, residential and office building application. But they use it for noise abatement as noise barriers along highways as well. So that's the stuff you see when you drive along your highway and there's a town behind it, and you don't want to create too much nuisance for them with the noise from the highway, or in this case, a railroad. That's when they built these walls, again, in all sorts of shapes and sizes and applications. Again, because it's cement coated, because it's water resilient, it's weather resistant. And that's why they can put it in between the railroad tracks to mitigate noise. Just a few more examples. Again, one can go fancy on design. And then on the right side, this A-frame or A-shaped example. This is fairly new. That's a contractor in the Netherlands that has developed this concept. He's about to patent it right now. And so based on that, oh yeah, so again, some more examples. And then the lower left, that wall actually does exist in California. That's along a golf course along I-5. The golf course was threatened to have one of the tournaments pulled because the noise from I-5 was too much. So they try to figure out what to do about it, and yeah, develop this noise barrier system out of the wood wool cement panels. So I did some math and thought, well, California installs about almost 60,000 linear feet of noise barriers every single year. And based on these calculations, a plant running at full capacity with one shift could produce all these panels in 1 year. Now, when I bring this material up to people, they often say, well, cement is bad. I said, well, cement is not bad. I know cement has a high carbon content, right? Emission content, because it takes a lot of energy in cement kilns to make the cement. Is it? Yes, that's true, but it depends on where does that energy come from, right? Does it come from coal? Does it come from gas? Does it come from solar and wind? Then that equation changes. And in the context of this comparison, right now, the entire 60,000 linear feet of noise barriers in California are built out of solid concrete blocks. So if we can substitute some of that cement, some of that concrete with locally grown overabundant small tree material, still add some cement to it and have a similar effect, maybe even better effect, because these walls do not bounce off noise as regular concrete walls do. So that's one of my pitches with them that I'm talking with Caltrans here, the Department of Transportation, to consider that. Trying to find markets for this product. How much goes into a plant? Not a whole lot. And when I talk to Forest Service people, they would rather see a plant that takes in 100,000 tons a year. I said, yeah, that's not this. It takes about 20 tons of wood per day per shift. So over a year, that's about 6,000 tons. It's peanuts. It's barely makes a dent. But I think with that size, it might lend itself to be more distributed into smaller communities and closer to the source. You don't have to have a centralized plant where you have to ship a lot of material in, but you could have this more distributed setup. In terms of sustainability and life cycle analysis, all or most of the European manufacturers, where all the manufacturers are these days, and then somewhere in Asia, in China, they have environmental product declarations, which is very similar to a to calculate the embedded carbon and emissions in general. Life cycle analysis, that's the word I was looking for. So they have these documents. For some reason, they do not exist to that extent for similar materials here. So if you look for an EPD for CLT, for example, they usually just go from they just go to the factory gate, and they do not encompass the whole chain from production to at the end of the life cycle. Where does the material go and what happens? Transportation costs, emissions, installation, and such. Yeah, just a few examples from a potential facility. The building is between 200 by 600 feet. The land with log storage and all that kind of material. Where do you cure the panels once they're in their molds? You're looking at between 8 and 12 acres. In terms of investment, it's between 6 and 17 million, depending on the product line and level of automation. The more automation, the more expensive it gets. The inverse is true for personnel per shift. The more automation, the fewer people I need. But you're looking at something between 12 and 22 employees per plant. So where does that tie into a variety of the issues we're dealing with in this group and on the state level? One is resilient forests and landscapes, because it does utilize underutilized small diameter trees, community hardening, home hardening. As I mentioned before, this material is fire resilient, not fireproof, but fire resilient. For the economic stimulus, between 12 and 22 personnel per plant. It plays well with mass timber. It's not a substitute. It does not have the structural strength as mass timber, but it has other qualities and characteristics that CLT does not have. So if you build an entire structure out of CLT, it's not quite an echo chamber, but it's close. And you still need siding and cladding on the outside, because I don't think many people would just leave CLT mass timber exposed to the elements. And it would be a good combination with other wood product manufacturers. So that's whether the co-location comes in, or the concept of the wood products campus. So now the big question, why is it not being used more in the US? Currently, there is no manufacturer in the US that makes this material. There's one in Ohio that makes similar product, but they use aspen, only aspen, and they use a different binder that is not as water resilient. So what I showed you earlier in moist and high humidity applications like swimming pools, exterior applications, that other product does not perform as well as wood cement, just because cement cures and then becomes water resistant. And so the US currently imports about just short of 500 shipping containers every single year of this material from both Europe and China. And so we're trying to make the case, well, can we produce some of this here and can we expand the market? And I'm hoping, or one idea would be, let's follow the path of CLT. 6, 7, 8 years ago, CLT was not a thing in the US, even though it was developed early 90s in Europe. So it took a long time for it to make it into the market here and to become an established building product. And now it's all the rage. Can we copy some of this for wood wool cement? Maybe, at least I hope so. And with that, I'd like to wrap up and open it up for questions.
Well, Martin, I am really impressed by this. This is Anne for everybody. And I, that's, so many of the questions that I had, you really answered. It was a great presentation. Why aren't we doing this here? Or more of this here? And so, and I think especially, as the economy is turning more to hopefully a green economy that we're seeing, is there a way that this could be, I think you said in the beginning, maybe you're looking at a grant or something like that, but how do we get this into the market and at a faster pace? Because this seems so incredibly promising. And especially when I was looking at that this can be used on highways and for sound barriers, which is so needed, I think, in so many different areas. You would think that we could really get this out onto market, increase the demand, and get some of this biomass off of our forests a lot quicker than we are right now. And especially with the huge fires, one would think that this could be expedited. But I just want to, what's the feeling right now that you're getting?
There's several challenges. One is it is not really in the building code. The acoustic panels that I mentioned at the beginning, they are in the building code, right? I mean, they are being imported, they are being installed. So that's taken care of. Other than that, nobody, well, very, very few people in the US know about this material. There are no contractors who've ever touched it. There is no Department of Transportation that is aware of it. So it's a matter of awareness. Again, very similar to CLT, to cross-laminated timber. The first CLT that was installed in the US, that's my understanding, as in a residential home, was imported from Canada. Most of the CLT that was first manufactured in the US ended up as temporary bridges for logging roads in the oil and gas fields in eastern Montana, and as a kind of platform to stage equipment. It only slowly worked itself into building codes, and California only adopted it last year in a multi-story construction. A big part is getting it in front of people, getting it in the hands of people. I have small hand samples here that the manufacturer from the Netherlands sent me, but that's about it. And I've talked to potential investors, and they say, well, we don't know a manufacturer who could make these things and market these things. So no, we're not looking at it. I talked to the cement industry in California, said, hey, you guys are catching quite some flack, and there is the competition from mass timber is increasing to your product. Here's something where you could combine some of your product, cement, with almost a nuisance product, which is small diameter timber, and green your industry, if you will. But yeah, it's been tough. That's why I just keep making these presentations at a variety of venues and hope to get into the right ears.
Well, I'll open it up to other people. I just want to do a quick follow-up, Martin, that maybe at some point I could have you come into a Fry meeting, the Forest Restoration Initiative. I think they'd be really interested in this. And if you want to get the word out, the second analysis area RFP has will be awarded fairly soon. I'd love them to see this. I just think this is incredibly promising. So I'll touch base with you on that. And maybe you could do it for the Fry stakeholder group. And these are stakeholders across the states, very well attended.
Yeah, absolutely.
Okay, great.
And Martin, just a quick follow-up. What was the response or general feedback from the cement industry folks you connected with?
The moment I mentioned the fact that there is rising competition from the mass timber side of things, they stopped communicating. So yeah, I mean, again, I was trying to get high enough in the food chain to just to listen, and maybe just give me an elevator speech, or let me give them an elevator speech or this presentation, or show them one of the hand samples I have here. But yeah, it pretty much died after I indicated, well, I'm aware of the competition you're facing. And even though they have a on their website how they're all greening their business, yeah, they didn't want to take this yet. Maybe, I don't know. So not very receptive.
Hey, Martin, it's Julie Keys in Montana. Thanks for the presentation. Yeah, it's a cool product, and hopefully it comes to market. I know that, specifically in Montana, in Clancy, Montana, there is both a cement plant and a mill. And I know that said mill has approached the cement plant about just trying to, use biomass in some of their firing. And that hasn't worked out, but I wonder if a proposition to them to do a value-added product with their combined product like this would work, but I think they'll need to see the demand first. So I'm going to watch the market. And I apologize, I made it a little late to your presentation. I don't know if you talked about, in terms of the wood fiber products, engineered products like loose fill and others that either have no cement additive or no adhesive additive, or the ones that do have an adhesive additive. I mean, is that further along in market potential than something that has cement in it? And do you know if that's accepted in building codes and that sort of thing?
Again, I think it's getting there. I know wood fiber insulation again has been imported to Montana. I met the gentleman was it 2 years ago when we were up there for the fun meeting, and now what's the company on the East Coast? Go something. They are building a wood fiber insulation plant, I think in Maine. Yeah, and again, these are products that are in the building code. They're easily adopted. Just like, so at the beginning, I talked about the panels, the thinner material, that's for acoustic wall and ceiling panels, and they are being installed in the US. They are being imported to the US. What is not a thing yet are these full wall elements similar to CLT, where you can build an entire structure, entire residential home within, yeah, a couple of days and have it dried in with this kind of material.
Thanks.
Hey, Martin, this is Damon. Really enjoyed the presentation. This is a super interesting product. I had a question mostly about the suitability for a species like ponderosa pine, which is really knotty and really tapered. Does that work well with the manufacturing process for this? Like I noticed in the picture you have here, even a 2-foot section of ponderosa pine usually doesn't look that nice. it'll have plenty more knots, and even a short one will be pretty tapered. So yeah, I guess I'm just wondering if you know if that would work, or if they've done studies on that or anything.
I did ask. So there's one manufacturer in Europe that builds the turnkey plants. So there is only one manufacturer in the world that builds the plants. And I asked him about, hey, what about if you have some more knotty wood? And he said it shouldn't be a problem. I mean, what we saw there at the beginning, I mean, this was some spruce and pine from most or more managed forests in Europe. But he said that shouldn't be a problem. So, and taper doesn't really matter. I mean, the smaller your diameter gets, you lose efficiency, right? Because you need to peel and process smaller material. But yeah, down to 4 inches, no problem. He said you can go even smaller, but your efficiency really takes a nosedive. So it's just a matter of debarking it, and I mean, adjusting the moisture content is one thing. The important piece in the storing it for several months in the yard is for tannins and sugars and whatever stuff to settle and cure, so it doesn't interfere with the curing process of the cement. Does that answer your question?
Yeah, definitely. Totally. Thanks.
What do you think, Damon, about something like that, like in a wood campus, or, you know, if the training center goes well?
It seems like it would fit in very well.
Again, it uses a relatively small amount of feedstock. And as I mentioned earlier, if I talk to Forest Service people, Larry Swan here, I mean, he just scoffs at it, and they say, well, do you have something that takes 100,000 tons a year? You get my ear. But I'm exaggerating. Larry's a fantastic guy. So, but yeah, it's just not on the scale that the state is really looking for. And that's what, again, makes it a little bit harder. But I think it opens opportunities as well. If we're not, again, speaking for California, if we're not looking at a more or less central facility close to I-5, which is the main axis going through the state and down in the valley. But if you want to locate something more into smaller forested communities closer to the source, I think something that uses 6,000 tons a year and employs, I don't know, 20 or 15 people should be a feasible option. It's not the end all be all, but should be a piece of the puzzle, especially since it makes a product that doesn't have anything to compare with.
It seems like there'd be fewer barriers to entry for kind of a smaller scale facility like that.
You just have to have the CapEx, yes, which it is my understanding is lower than a CLT plant, for example. Especially, I mean, some people say, well, we can make CLT out of smaller diameter material. I said, yes, but your costs go up, and so your margin becomes even smaller. So yes, I know you can make small diameter mass timber, but how cost efficient is it if you compare it with conventional building products?
Martin, I have another question. What's the proportion of wood to cement? You might have said it and I didn't catch that.
Yes, so it's the wood, no, where is it? Oh, maybe I took it out. Wood to water to cement is 1 to 1 to 2 by weight. Cement is heavy, right? So yeah, it's 1 to 1 to 2 wood, water, cement by weight.
By weight, okay.
That's important.
Great. Any other questions or comments? Tom, you must have something.
You must have just saw me turn my mic off. Yeah, no, thanks, Martin. This is great. I don't know if just for a good overview of the product and some of where it's at. Yeah, Martin did mention that we're working on a kind of a market analysis, looking at both this product and wood fiber insulation through the Council of Western State Foresters Forest Utilization Network. I think that RFP should go out. I mean, fire will slow things down, but hopefully it'll be on the streets before the end of the summer. And again, that'll be recruiting a consultant to really help quantify investment costs, feedstock requirements, markets, and then kind of write up some of the barriers Martin was discussing. I don't know. My sense is, I mean, we really for folks that are tied in with the mass timber scene and the build design sector, we really need to be talking. We need to get an architect excited, someone who's in that, who's passionate about sustainability through construction, and get it cladding a high profile project, or just find through our network with build design sector, find someone who we can get excited about it, that wants to put it out there and showcase it. Because I think that's like Martin said, like the product isn't really known here. There are alternative means processes for someone who really wants to get it in a building. And again, that's not us, that's the architect and the engineering team. So I think it's really finding the right people in that sector who we can help, who would be interested in helping champion this, I think is kind of a key step.
And one piece I'm still chasing is a comparison of embedded carbon, just in the, let's say, standard residential building, 1,400 square feet, 1,600 square feet, whatever, and do a comprehensive embedded carbon calculation, comparing conventional stick frame building, what we do now. I mean, even if it's advanced construction, what goes in, right? Because if I just build with 2x6s, I still need to get some insulation in there. I still need to put something on the inside, so that's usually drywall. I need to put something on the outside, and it's often hardy plank, which contains cement. So you need to have a rain screen behind it, and so there's a lot of different pieces, components that go into this assembled structure, but we don't have that. It doesn't exist. And then we could compare, okay, how does that compare conventional building style versus a building out of CLT versus a building out of wood wool cement, right? Because all these bits and pieces will have transportation costs, emissions, production of these different components will have emissions, and wood wool cement, the large wall elements, combine insulation, fire resilience, and moisture resistance, breathability for indoor climate. So finding funding for that would be great. It's not easy. It's a very complex thing to do, but yeah.
It seems like that market analysis could really help drive toward the funding for that piece, Martin. It seems like kind of a 1, 2, 3 step thing. Or if you could figure out, okay, high carbon input products like just cement itself, what can be replaced with wood wool cement, and what is that, potential market? And then you can really see the scale of the potential to change. Look, we're talking about this much material that could be produced with a more efficient product that has more desirable properties. Let's see how much, carbon climate impact we can have.
Right. Yeah, I think we decided we can't put that in the market assessment study, because that's a very different calculation to do. So maybe we can, I hope to find funding for that somewhere else. I mean, it'll be somewhere a piece in there, but we don't have this comparison between CLT and conventional construction. It's just going to be, the RFP will be around wood wool cement and wood fiber insulation.
Okay.
Tom, correct me if I'm wrong, but that's my understanding.
I was just thinking, I hope the numbers that come out of that will be really valuable to help secure the funding. Yes. For the carbon piece.
Yeah, and just giving us some numbers so I can go back to the investors and say, hey, it doesn't look that dire. I mean, there's actually, and that's why I put this my math for the highway the highway noise barriers for California in there. I mean, that would be an entire plant operating a full shift all year, just to crank out enough panels for California and substitute a significant amount of concrete, cement.
Yeah, and I was, Martin, I was just watching a piece yesterday on the news about, how the wildfire smoke is traveling. I'm sure you all have heard it, to New Jersey and to New York. And if you think about, insulating buildings, that might be a selling point, honestly, and it was interesting that, one of the folks on the spot said something like, well, rich people, even though you think, oh, we all breathe the same air, we can't get away from it. But people with money, they were saying, well, people with money, you'd be amazed what they can do. They can, build buildings and do things where they don't have to always share the same air, but that could be a selling point.
Yes.
That insulation quality, so. Okay, we got about five minutes left. So I just had a few announcements, but did anybody else have anything else they wanted to say before we switch gears? Well, Martin, thanks so much. And like I said, I might see if we can't get you on the Fry stage at one point. I think this was excellent information and a really exciting product.
Yeah, let me know. Sounds good.
Okay, so just very quickly, the next wood COP call is September 23rd, and Damon Vaughn, who's on the call today from ERI, Ecological Restoration Institute. Damon, are you still up for presenting that information in September?
Yes, I can definitely do that.
Okay, so it's workforce training needs of logging, mastication, and trucking in the Southwest, and it's the findings, which I think will be really interesting. I'm really looking forward to that. And then the one thing I want to let everybody know about too, in November, our call falls during Thanksgiving. So we had changed the date in Podio, but when I looked at that, that date is the same date as your wood utilization conference, Damon. So I wanted to change that because of the conference. And then when I looked at the Thursday after that, that's just before Veterans Day. So I thought that's not going to work. So two suggested dates are Thursday, November 4th or Friday, November 19th. And this would be at the same time, Mountain Time, 10:30 Mountain Time. And so I didn't know if anybody has a preference or if we should just select it and send that date out, or Becca, if you have a preference.
You said November 4th or 15th?
November 4th or November 19th, which is a Friday. November 4th is a Thursday. I think it's the first Thursday.
My gut tells me Thursday would probably be better.
Okay, so maybe we'll switch it to November 4th and we can put an announcement out. Okay, let's just do that. Just wanted to let everybody know about that. We did have a few suggestions for that call. Either we could invite Good Earth Power has a new mill here in Arizona. Somebody else brought up an idea of the Vaughan Brothers CLT buildings, but I didn't know if anyone had suggestions, or we could also have more of an open call and no presentation.
Did I see that the Vaughan Brothers plant was closing? Or is that a different plant in the Northwest? Somebody know?
I think that
Might have
was
been Katera.
the other one.
Tara.
Tara.
Okay. Oh, okay. I knew I'd seen that. Something was closing down.
Or if anybody else has other ideas, and of course we can revisit this in September, we don't have to decide, but just think about, if there's something like what, similar to what Martin presented, something that's really, hot off the press, or you want to increase awareness for a new product or a new technology. Just think about that. Like I said, we don't have to decide right now, but if there's something that we all want to look at or discuss, just let us know and we can see if we can get that arranged.
Here's one to consider and I guess it depends on if folks have already been in the loop with the EcoStrat about the Bioeconomy Development Opportunity Zone initiative they have.
Okay.
I'm sure they would probably be willing to join and present.
Oh, that sounds really interesting. Is there a way, Tom, maybe after this, you and I could connect and see if we could get that set up?
Yeah, excuse me. Yeah, I can send you their presentation, and if you think it's a good fit for the group, yeah, I think it's super easy to set it up if you think it fits.
Okay, that's perfect. I'd love to look at that. Thank you. All right. Did anybody have any announcements or anything they wanted to bring up before we end? I think we're at time, but was there something that was important that you wanted to bring to the attention of the group? Okay, well, I appreciate everybody's time. I thought this was a fantastic presentation, Martin. Thank you so much. And all of us will help spread the word.
Very good. Thank you.
So you've done your job, and we'll continue because awareness is, that's your first step, is that awareness piece. And so I think because we all know about it, that we can help you move this along. So really appreciate your time. I also wish you luck with the fires. It's probably not the greatest feeling in the world, but I hope you don't have to evacuate.
Yeah, hope so too. Last year it came within a couple of blocks, at least, the evacuation warning. So we're doing better this year so far.
Well, that's good. No, that's definitely good. So great. We'll also get this posted up on Podio for those who missed it. And then Martin, I see your the link in the chat. I don't know why I can't copy it. Oh, there, I get it. I got it. Never mind. I'm going to copy it, and then we can put that up there with the recording as well.
Yeah,
So
if you want, I can send you the slides as well. And
that would be great.
Okay.
Yeah, we'd love to post it too, because I bet you there were a lot of people that weren't here that would love to tune in.
Yeah, sound good.
Great. Well, so good to see everybody. I hope you have a great August, and we will see all of you in September.
Sounds good. Thank you.
Okay,
Take
take
care.
care. Bye-bye.
Thanks, everybody.
Thanks, Becca.